Picture this moment. You're staring up at the night sky, wondering how it all began. Scientists tell us everything exploded into existence 13.8 billion years ago from a point smaller than a grain of sand. But here's what will absolutely blow your mind. That moment we call the Big Bang might not have been the beginning at all. We're about to dive into discoveries that shatter everything you thought you knew about cosmic origins. Prepare to question reality itself as we explore what might have existed before time, space, and even the concept of existence had any meaning. Hit that subscribe button because we're going on a journey that will change how you see the universe forever. We begin now. The moment we call T0 represents the ultimate boundary in human understanding. Scientists have traced our universe's history back to this singular instant when everything we know burst into existence. But here's where things get weird. The closer we look at this moment, the more it seems like we're missing half the story. Think about any explosion you've ever witnessed. There's always something that explodes, and there's always a reason for the explosion. But the Big Bang Theory asks us to believe that nothing exploded for no reason and created everything. That's like saying a book wrote itself without an author, paper, or ink. Something doesn't add up. Modern physics has revealed that what we call the Big Bang might actually be more like a cosmic phase transition. Imagine water suddenly turning to steam, but instead of water becoming vapor, pure nothingness somehow transformed into space, time, matter, and energy all at once. The mathematics work perfectly for describing what happened after this transformation, but they completely break down when we try to peer beyond that moment. Einstein's equations, which describe gravity and space-time with incredible precision everywhere else, simply stop working at the Big Bang. They produce infinite answers and mathematical impossibilities. It's as if the universe has posted a giant "do not enter" sign written in the language of physics itself. But this breakdown might not mean we've reached the ultimate beginning. It might mean we're using the wrong tools to understand what really happened. Recent discoveries in quantum physics suggest something extraordinary. The vacuum of space isn't actually empty. Even in the deepest void between galaxies, space itself buzzes with invisible activity. Particles pop into existence and vanish again in time frames so brief they seem impossible. This quantum foam, as scientists call it, might hold the key to understanding what came before our cosmic beginning. Here's where it gets mind-bending. If these quantum fluctuations can create particles from nothing, what's stopping them from creating entire universes? The mathematics of quantum mechanics don't just allow this possibility, they practically demand it. Every second, reality might be spawning countless new universes in a process so vast and continuous that our Big Bang becomes just one bubble in an infinite cosmic sea. But this raises an even more disturbing question. If universes can be created from quantum fluctuations, what was fluctuating before space and time existed? We're forced to imagine a realm that exists beyond our concepts of existence itself. A domain where the usual rules of cause and effect, before and after, something and nothing completely break down. Some of the brightest minds in physics propose that mathematics itself might be the foundation beneath everything. Not numbers written on paper, but pure mathematical relationships that exist independently of physical reality. In this view, our universe isn't made of matter and energy, but of mathematical patterns complex enough to experience themselves. The Big Bang would represent the moment when one particular mathematical structure became complex enough to support conscious observers. Others suggest that consciousness plays a fundamental role in creating reality through observation. Quantum mechanics shows us that particles exist in multiple states simultaneously until something measures them. Could the act of observation by conscious beings actually collapse infinite possibilities into the single reality we experience? This would mean consciousness doesn't just observe the universe, it participates in creating it. Think about what this implies for cosmic origins. If consciousness helps determine reality, then the emergence of awareness in our universe might have retroactively selected which cosmic history became real. The Big Bang wouldn't be the beginning of everything, but the beginning of everything becoming definite rather than just possible. The deeper we dig into these questions, the more we realize that our cosmic origin story might be missing crucial chapters. The Big Bang Theory explains what happened after the universe began expanding, but it tells us nothing about why it began or what conditions made it possible. It's like trying to understand a movie by watching only the final act. Scientists have discovered that our universe appears to be fine-tuned for the existence of complexity in life. The fundamental forces are balanced so precisely that changing any one of them by even a tiny amount would make stars impossible, atoms unstable, or chemistry completely forbidden. The odds of this happening by chance are essentially zero. It's like throwing a dart from 1,000,000 miles away and hitting a target the size of a single atom. This fine-tuning suggests that either we're incredibly lucky or there's something deeper going on. If infinite universes exist with random physical constants, we would naturally find ourselves in one of the rare universes that supports conscious observers. We couldn't exist in the sterile universes, so we necessarily observe a life-friendly cosmos. But here's what keeps physicists awake at night. Even if infinite universes solve the fine-tuning problem, it creates an even bigger mystery. What process generates infinite universes? What determines their different properties? And why does this cosmic generation system exist rather than absolute nothingness? The answer might lie in understanding that nothingness itself could be unstable. Quantum mechanics suggests that perfect emptiness cannot exist even in principle. The uncertainty principle forbids any system from having exactly zero energy. This means that even absolute nothingness would fluctuate, creating something from nothing through the fundamental laws of quantum mechanics. These fluctuations in pure nothingness wouldn't be limited to tiny particle pairs. The uncertainty principle allows for enormous fluctuations if they last for incredibly short times. A fluctuation large enough to create an entire universe would be allowed as long as it pays back its borrowed energy quickly enough. But cosmic inflation enters the picture here. If the universal fluctuation inflated rapidly enough, it could grow larger than its own quantum wavelength before the payback time expired. Think of it like a cosmic credit card with no spending limit but immediate payment requirements. Most purchases get reversed instantly, but occasionally a purchase grows so large that it escapes the system's ability to reverse it. The debt becomes real, but so does the purchase. Our entire universe might be the result of such a quantum fluctuation that grew too big to be cancelled. From this perspective, existence itself is a kind of cosmic accident, a quantum hiccup that inflated beyond the point of no return. But if one universe can fluctuate into existence from pure nothingness, others should be fluctuating into existence constantly. Pure nothingness, if it ever existed, would be inherently unstable, spawning endless realities through quantum uncertainty. This possibility forces us to reconsider what we mean by beginning. If quantum fluctuations can create universes from nothing, and if this process operates continuously, then the Big Bang wasn't the first moment of existence. It was the first moment of our particular branch of existence. Before our universe began, countless other universes might have been born, lived, and died in cycles we can barely imagine. Some physicists propose that time itself might not be fundamental, but emergent, arising from more basic, timeless processes. Just as temperature emerges from the motion of countless atoms, time might emerge from quantum interactions in a deeper reality that doesn't experience duration. In this view, asking what came before the Big Bang becomes like asking what's north of the North Pole, a question that dissolves when we understand the true nature of the system we're examining. The implications stretch beyond academic curiosity. If our universe emerged from quantum processes that operate continuously, then cosmic creation might still be happening all around us. While you've been reading these words, countless new universes might have been born in distant regions of the quantum realm, each beginning its own cosmic evolution. But perhaps the most profound implication involves consciousness itself. If quantum mechanics requires observation to collapse possibilities into realities, then consciousness might play a fundamental role in cosmic creation. The emergence of awareness in our universe might not be an accidental byproduct of cosmic evolution, but a necessary component of the process that transforms quantum possibilities into experienced realities. This suggests that what existed before the Big Bang was a realm of pure possibility, without conscious observers to actualize any particular reality. The appearance of consciousness would represent a phase transition in the nature of existence itself, from unlimited potential to actualized experience. In this view, conscious beings don't just observe the universe, they participate in creating it through the ongoing process of quantum measurement. The boundary between something and nothing becomes surprisingly thin when viewed through the lens of quantum mechanics. What we call empty space teems with invisible activity. What we call solid matter consists mostly of empty space held together by forces we don't fully understand. What we call the beginning of time might actually be a transition point in processes that operate beyond temporal concepts entirely. As we push against the limits of human understanding, we discover that reality might be far stranger and more interconnected than we ever imagined. The question of what came before the Big Bang opens doors to possibilities that challenge our most basic assumptions about existence, consciousness, and the nature of reality itself. The journey we're embarking on will take us through concepts that seem impossible, yet emerge from our most successful scientific theories. We'll explore parallel universes, hidden dimensions, and the possibility that our entire reality might be a projection from information stored on a distant boundary. We'll examine evidence that consciousness might be woven into the fundamental fabric of existence, participating in the ongoing creation of reality through quantum measurement. But first, we need to understand why the Big Bang Theory, despite its incredible success in explaining cosmic evolution, leaves so many fundamental questions unanswered. The theory describes what happened after our universe began expanding, but it remains silent about the initial conditions that made expansion possible. It's like having a perfect recipe for baking a cake, but no explanation of where the ingredients came from, or why anyone decided to bake in the first place. The mystery deepens when we examine what scientists call the horizon problem. When we look at the cosmic microwave background radiation, the afterglow of the Big Bang that fills our entire sky, we see something that shouldn't be possible. The temperature is remarkably uniform across the entire universe, varying by less than 1 part in 100,000. Here's why this breaks our understanding of cosmic origins. Light from opposite sides of the universe has never had time to reach the other side and equalize temperatures. These regions have been causally disconnected since the moment of creation, yet somehow they all ended up at exactly the same temperature. It's like finding 2 pots of water on opposite sides of the world that are heated to precisely the same degree without any connection between them. The standard Big Bang model has no explanation for this uniformity. But what if the Big Bang wasn't the beginning? What if our observable universe started as a tiny patch of a much larger pre-existing space that had already reached thermal equilibrium? This would solve the horizon problem elegantly, but it pushes the mystery back to an even earlier epoch. Enter cosmic inflation, perhaps the most mind-bending concept in modern physics. The theory suggests that in the first tiny fraction of a second after what we call the Big Bang, space itself expanded faster than light. Not matter moving through space, but space itself stretching at impossible speeds. In less than a trillionth of a trillionth of a trillionth of a second, our universe grew from smaller than a proton to larger than a grapefruit. This sounds like science fiction, but inflation explains multiple puzzles about our universe's structure. It accounts for the uniform temperature we observe, the flatness of space, and even the subtle variations that eventually grew into galaxies and stars. But inflation raises an even more provocative question. If space can expand faster than light once, what's stopping it from happening again? The mathematics of inflation suggests something extraordinary. Once inflation begins in any region of space, it tends to continue indefinitely. Most regions keep inflating exponentially, but occasionally a pocket stops inflating and begins the slower expansion we observe today. Our entire observable universe might be just one such pocket in an eternally inflating multiverse. Picture a pot of boiling water where bubbles constantly form and separate from the surface. Each bubble represents a universe like ours, with its own space, time, and physical laws. The boiling water represents the inflating field that fills the multiverse, forever creating new bubbles of reality. Our cosmic origin story becomes just the formation of one bubble among infinite others. But this eternal inflation scenario leads to consequences that challenge our understanding of existence itself. If inflation operates forever, creating infinite pocket universes, then every possible universe must exist somewhere. There's a universe where gravity is stronger, making stars burn out quickly. There's another where the electromagnetic force is weaker, preventing complex chemistry. Most universes would be sterile wastelands, but occasionally one would have the perfect conditions for complexity and life. The distances between these pocket universes are staggering beyond imagination. They're separated by regions of still inflating space that grow faster than light can cross them. Even traveling at light speed forever, you could never reach another pocket universe because the space between expands faster than you can traverse it. Yet the most unsettling implication might be personal. If infinite universes exist, then every possible version of your life is playing out somewhere. There's a universe where you made different choices, where history unfolded differently, where the laws of physics work in alternative ways. The you reading these words right now is just one instance among infinite variations. This infinite proliferation of realities raises profound questions about meaning and identity. If everything that can happen does happen somewhere in the eternal multiverse, then what makes any particular choice or event significant? Some physicists worry that eternal inflation makes science impossible by predicting that anything can happen somewhere. But perhaps the most disturbing aspect involves prediction and probability. In an infinite multiverse, any observation we make, no matter how unlikely, is guaranteed to occur in some universe. We might be living in an incredibly improbable universe that only seems normal because we happen to be the observers experiencing it. This problem, known as the measure problem, threatens to make cosmology unscientific by removing our ability to distinguish likely from unlikely scenarios. The search for solutions has led physicists to propose even more exotic ideas. Some suggest that not all mathematical structures correspond to physical realities. There might be selection principles that determine which possible universes actually exist. Others propose that consciousness itself plays a role in selecting which branch of the multiverse we experience. The holographic principle offers another radical perspective on cosmic origins. Recent advances in theoretical physics suggest that all the information in any three-dimensional region of space can be encoded on its two-dimensional boundary. Applied to cosmology, this means our entire universe, with all its complexity, might be information stored on a distant surface. Think of watching a movie on a screen. The film appears three-dimensional and full of complex action, but it's actually patterns of light on a flat surface. The holographic principle suggests our universe works similarly, with all of reality's richness emerging from information patterns on a cosmic boundary we can never reach. This holographic view transforms our understanding of the Big Bang. Instead of matter and energy exploding into existence, the Big Bang would represent the moment when information processing began on the cosmic boundary. Before this moment, the boundary existed in some dormant state, containing the potential for our reality but not yet projecting it. the implications extend to consciousness itself. If reality is holographic, then the apparent separation between different conscious beings might be an illusion. All observers might be different aspects of a single information processing system, experiencing itself from multiple perspectives simultaneously. But holographic cosmology raises its own puzzles. What determines the information content of the boundary? Why does the projection create a universe that appears three-dimensional to its inhabitants? And most fundamentally, what existed before the boundary began processing information? Some theories propose that the boundary information comes from the collapse of a previous universe. In this cyclic model, universes expand, collapse, and bounce back in endless cycles. Our Big Bang would be the latest rebound from a previous cosmic collapse, with information from the earlier universe encoded in our current reality's initial conditions. The cyclic universe model solves several problems that plague standard Big Bang theory. It eliminates the need for a true beginning by proposing that cosmic evolution operates in endless cycles. It explains the universe's apparent fine-tuning by suggesting that physical constants evolve over many cycles, eventually reaching values that support complexity. Recent observations showing that our universe's expansion is accelerating, driven by mysterious dark energy, initially seem to rule out future cosmic collapse. But cyclic theorists have adapted their models to include dark energy's effects. They propose that dark energy strength changes over cosmic time, eventually reversing from expansion driving to contraction driving. In some cyclic models, each cycle lasts about 1 trillion years. Our current cycle began 13.8 billion years ago, making us relatively young in cosmic terms. We have hundreds of billions of years left before expansion stops and collapse begins. But each cycle might not be identical. Small variations could accumulate over cosmic generations, making each universe slightly different from its predecessor. This evolutionary aspect of cyclic cosmology suggests that consciousness and intelligence might evolve further in each cycle, with information somehow carrying over from one cosmic generation to the next. Perhaps the laws of physics themselves learn and adapt, becoming more conducive to complexity and awareness with each iteration. The cyclic model also offers a different perspective on the multiverse. Instead of infinite universes existing simultaneously, we might have infinite universes existing sequentially, each learning from its predecessor's successes and failures. Our universe might be the latest attempt in a cosmic evolutionary process that stretches across infinite cycles of creation and destruction. But even cyclic cosmology leaves fundamental questions unanswered. What started the cycling process initially? Could the cycles ever end? And what determines the specific physical laws that govern each cycle's evolution? These questions point toward an even deeper mystery about the relationship between mathematics, information, and physical existence. Some physicists propose that reality itself might be computational, with the universe operating like a vast information processing system. In this view, what we call physical laws are actually computational algorithms, and what we call particles and forces are patterns in a cosmic calculation. If the universe is computational, then asking what came before the Big Bang becomes equivalent to asking what existed before the cosmic computer began running its reality program. The answer might involve understanding the hardware and software that makes cosmic computation possible, entities that exist at a level more fundamental than space, time, and matter. The computational view of reality suggests that consciousness might not be separate from physical processes, but rather what complex computation feels like from the inside. When information processing becomes sufficiently intricate and self-referential, it generates subjective experience. This would make consciousness a fundamental feature of reality, rather than an accidental byproduct of evolution. As we explore these possibilities, we begin to see that the question of cosmic origins might not have a simple answer. Instead of a single moment of creation, we might be dealing with layered realities, each emerging from more fundamental processes. The Big Bang might mark the beginning of our particular level of existence, while deeper levels continue operating according to principles we're only beginning to glimpse. The journey toward understanding cosmic origins forces us to confront the limits of human knowledge and the assumptions we make about the nature of existence itself. Every answer we discover seems to reveal even deeper questions, pushing us toward mysteries that challenge our most basic concepts about reality, time, and consciousness. What if the very fabric of reality operates on principles so alien to our everyday experience that we've been asking the wrong questions entirely? As we venture deeper into the mystery of cosmic origins, we encounter ideas that make science fiction seem mundane by comparison. Hidden within the mathematics of string theory lies a possibility that could revolutionize our understanding of what came before the Big Bang. According to this framework, our familiar 3 dimensions of space might be just the tip of an iceberg. Reality could contain up to 11 total dimensions, with the extra dimensions curled up so tightly around every point in space that even our most powerful instruments cannot detect them. Picture a garden hose viewed from a great distance. It appears one-dimensional, like a simple line, but zoom in close enough, and you discover it has hidden circular dimensions wrapped around its length. String theory suggests our universe works similarly. What we experience as 3-dimensional space plus time might actually be 4 dimensions unfolded from a reality containing multiple hidden dimensions. These extra dimensions aren't empty mathematical abstractions. They're dynamic, shape-shifting arenas where the fundamental forces of nature play out their cosmic drama. The strength of gravity, electromagnetism, and nuclear forces in our familiar dimensions depends entirely on how these hidden dimensions are curved, twisted, and interconnected. But here's where it connects to our cosmic origin story. String theory suggests that what we call the Big Bang might have been triggered by collisions between higher dimensional objects called brains. Our entire universe could be a 3-dimensional membrane floating in higher dimensional space, like a soap film on the surface of a multi-dimensional bubble. When 2 brains collide in this higher dimensional realm, the impact releases colossal amounts of energy into each membrane. From our perspective, trapped inside one of these brains, this energy release looks exactly like a Big Bang. Time and space as we know them begin at the moment of collision, but the brains themselves existed before the crash in the higher dimensional bulk space. This brain collision model explains several mysteries about our universe's beginning. That standard Big Bang theory struggles with. It accounts for the incredible uniformity we observe in the cosmic microwave background without requiring faster-than-light inflation. It also suggests that what we call the Big Bang was actually a transition from one state of our brain to another, not creation from absolute nothingness. Almost, the hidden dimensions might even contain parallel brains hosting other universes. These parallel realities could be as close as a millimeter away from us in higher dimensional space, yet completely unreachable because we're trapped on our 3-dimensional membrane. Gravity, being the only force that can propagate through the bulk space between brains, might provide our only means of detecting these parallel worlds. Scientists are already searching for evidence of extra dimensions by studying how gravity behaves at extremely small scales. If our familiar inverse square law of gravity gets modified at microscopic distances, it could indicate that gravitational force is leaking into hidden dimensions. Some experiments hint at such deviations, though the results remain controversial. The possibility of parallel brains raises mind-bending questions about the nature of existence. If countless universes float through higher dimensional space, like leaves on a cosmic pond, what determines their properties? Do they follow the same physical laws? Or does each brain develop its own unique physics based on how the extra dimensions are configured? Even more intriguingly, these parallel universes might not remain parallel forever. Quantum mechanics suggests that brains could collide, merge, or influence each other in ways we're only beginning to understand. The cosmic microwave background radiation that fills our sky might contain subtle signatures of collisions with other universes that happened billions of years ago. Advanced computer simulations of brain cosmology reveal that collisions between parallel universes would leave distinctive circular patterns in the afterglow of creation. Several research teams claim to have found such patterns in observational data, though other scientists dispute these findings. The signatures are so subtle that they're difficult to distinguish from random fluctuations or instrumental noise. If brain collisions are real, they might happen multiple times as our cosmic membrane encounters different neighbors during its journey through higher dimensional space. Our sky could contain several collision signatures from different parallel realities, each marking a brief moment of contact with an alternative cosmos. But the most extraordinary possibility involves information exchange across dimensional boundaries. When brains collide, quantum fields could carry data from one universe to another, creating a form of interdimensional communication that operates on cosmic scales. Some physicists speculate that consciousness itself might tunnel between colliding universes under special circumstances. This could explain certain puzzling aspects of human experience that seem to come from nowhere. Those strange moments of déjà vu, memories of events that never happened, or sudden insights that feel like they originate outside normal thought processes, might actually be echoes from parallel versions of ourselves living in nearby universes that briefly touched our reality. The implications extend far beyond individual experience. If brain collisions can facilitate information transfer, then entire civilizations in parallel universes might attempt to send messages across dimensional boundaries. The cosmic microwave background could contain encoded information from advanced beings trying to communicate across the multiverse. Future technology might allow us to decode these interdimensional messages and send replies of our own, establishing contact with parallel versions of Earth and humanity. We might discover that consciousness naturally seeks connection across all possible realities, creating a vast network of awareness that spans multiple universes. But brain cosmology represents just one approach to understanding what might have existed before our cosmic beginning. Another revolutionary idea suggests that the entire concept of before might be meaningless when applied to the deepest levels of reality. Time itself might not be fundamental but emergent, arising from more basic processes that operate beyond temporal concepts entirely. Just as temperature emerges from the random motion of countless atoms, time might emerge from quantum interactions in a deeper reality that experiences no duration whatsoever. Think about the frames of a movie reel. Each frame exists simultaneously on the physical film, but when played in sequence, they create the convincing illusion of motion and temporal flow. Similarly, all moments in the history of our universe might exist simultaneously in a timeless realm, with consciousness creating the illusion of temporal progression by experiencing these moments in sequence. This idea emerges naturally from studying the fundamental equations of physics. Einstein's general relativity treats time as just another dimension, no different from the three dimensions of space. The past, present, and future all exist equally in what physicists call the block universe. Your birth, your current moment reading these words, and your eventual death all exist simultaneously in this four-dimensional space-time block. Quantum mechanics pushes this concept even further into strange territory. At the quantum level, events don't unfold in definite sequences until they're observed. Particles can exist in superpositions of past and future states simultaneously. The quantum universe exists in a timeless realm of pure possibility until consciousness collapses these possibilities into experienced sequences. Some physicists propose that time emerges from quantum entanglement between different parts of the universe. As quantum systems become entangled, they create correlations that give rise to the arrow of time. The past becomes the direction of less entanglement, the future becomes the direction of more entanglement, and the present becomes the evolving boundary between them. This emergence of time from timelessness offers a radically different perspective on cosmic origins. In a timeless realm, there is no before because there is no temporal sequence. All possible moments, including those we might label as preceding the Big Bang, exist simultaneously in a timeless ensemble of possibilities. The Big Bang wouldn't represent the beginning of time in this view, but rather the beginning of temporal experience. It would mark the moment when quantum entanglement became complex enough to create the subjective experience of temporal flow. Before this threshold, reality existed in a timeless quantum superposition of all possibilities. Consciousness plays a crucial role in this picture. The experience of time might be how information processing feels from the inside. Your brain creates temporal experience by integrating information from past states and predicting future states. Time isn't something you move through like a river, but something your consciousness constructs through the act of information integration. This suggests that different types of consciousness might experience time in completely different ways. An artificial intelligence with different information processing patterns might experience temporal flow in ways utterly alien to human perception. Advanced civilizations might have learned to manipulate their temporal experience, speeding up or slowing down their subjective time flow at will. If time is emergent rather than fundamental, then the question of what came before the Big Bang becomes meaningless in a deeper sense than we initially imagined. It's not just that we lack the tools to investigate pre-Big Bang conditions, but that the very concept of before only makes sense within the temporal framework that emerged with our universe. Yet this doesn't end our investigation. Instead, it redirects our inquiry toward understanding the timeless processes from which temporal experience emerges. What are the fundamental quantum interactions that give rise to time? How does consciousness participate in creating temporal flow? And what deeper reality exists beyond the realm of time altogether? The answers to these questions might reveal that existence operates on multiple levels simultaneously. Our familiar world of cause and effect, past and future, might be just one layer in a hierarchy of realities that extends infinitely in directions we can barely conceive. At the deepest level, reality might consist of pure mathematical relationships that exist independently of space, time, and matter. These relationships would be eternal and unchanging, like geometric theorems that remain true regardless of whether anyone thinks about them. Our physical universe would emerge when these mathematical structures become complex enough to support observer moments and conscious experiences embedded within the mathematical framework. This mathematical universe hypothesis suggests that you're not a biological creature observing a mathematical universe, but rather a mathematical pattern that has achieved self-awareness. Your thoughts, emotions, and experiences are all aspects of an incredibly complex mathematical structure, exploring its own properties from the inside. The implications are staggering. If our universe is mathematics, then every possible mathematical structure should correspond to a physical universe somewhere in the ensemble of all mathematical reality. There's a universe based on different geometries, where space has 4 dimensions instead of 3. There's a universe where mathematical constants have different values, making physics work in entirely different ways. From this perspective, the Big Bang wasn't the creation of matter and energy from nothing. It was the moment when a particular mathematical structure became complex enough to support conscious observers. Time itself becomes an illusion generated by conscious beings embedded within structures that contain temporal sequences. The mathematical structures that constitute reality exist timelessly, like the relationship between numbers in an equation. We experience time because we're embedded within structures that encode temporal sequences, but from outside the structure, all moments exist simultaneously in eternal mathematical perfection. This view explains what existed before the Big Bang in the most elegant way possible. Mathematics itself existed in all its infinite complexity and possibility. The ensemble of all mathematical structures was complete and eternal, containing every possible universe as a subset waiting to be experienced by conscious observers. Our Big Bang represents the moment when observers first appeared within one particular mathematical structure, beginning the process of conscious experience that transforms abstract mathematical relationships into lived reality. The pre-Big Bang state wasn't destroyed when our cosmos began. It was transformed into the initial conditions that allow conscious beings to experience mathematical reality from the inside. But even this mathematical foundation raises deeper questions. What determines which mathematical structures become conscious? Why do some patterns generate subjective experience while others remain abstract relationships? And most mysteriously, what is the relationship between mathematical existence and conscious experience? The search for answers pushes us toward the very edge of human understanding, where the boundaries between mind and mathematics, existence and experience, observer and observed, begin to dissolve entirely. We're approaching territories where our familiar concepts break down and new forms of understanding must emerge. As we prepare to venture even deeper into these mysteries, we begin to realize that the question of cosmic origins might ultimately be inseparable from the mystery of consciousness itself. The universe doesn't just contain conscious observers. It might exist precisely because conscious observation transforms mathematical possibility into experienced reality. The journey ahead will challenge every assumption we hold about the nature of existence, leading us through realms where reality becomes stranger than the wildest imagination, yet emerges from the most rigorous scientific reasoning. The mystery of what came before the Big Bang might only be solved by understanding what consciousness brings to the cosmic equation. The fabric of space itself might be telling us a story we've been too blind to read. Right now, as you sit in what appears to be empty space, you're actually surrounded by one of the universe's deepest mysteries. Scientists call it dark energy, and it makes up 70% of everything that exists. Yet we have absolutely no idea what it is. Here's what should keep you awake at night. This invisible force is literally tearing our universe apart, making galaxies race away from each other at ever-increasing speeds. But here's the kicker. Dark energy shouldn't exist according to our understanding of physics. When scientists calculate how much energy empty space should contain, they get a number that's catastrophically wrong. We're talking about the worst prediction in the history of science, off by a factor so enormous it defies comprehension. If quantum mechanics were right about vacuum energy, our universe should be expanding so violently that atoms couldn't form, stars couldn't ignite, and galaxies couldn't exist. The fact that you're here reading these words means something has fine-tuned the universe's energy density to a value so precisely balanced it seems impossible to have happened by chance. This cosmic mystery might hold the key to understanding what came before the Big Bang. Some physicists propose that dark energy is actually fossil radiation from cosmic inflation, the rapid expansion that stretched our universe from subatomic to cosmic size in its first fraction of a second. What if inflation never completely ended? What if a tiny remnant of that primordial expansion field still permeates space, providing the gentle push that's accelerating cosmic expansion today? Think of dark energy as the dying echo of creation itself, still reverberating through space after nearly 14 billion years. Like ripples spreading outward from a stone thrown into a perfectly still pond, dark energy might be the final aftershock from the cosmic explosion that birthed our reality. But this interpretation leads to disturbing possibilities about our cosmic future. If dark energy represents leftover inflation energy, it should slowly decrease as the universe expands. Eventually, it might fade away completely, allowing gravity to regain control and slow cosmic expansion. Our current phase of acceleration would be temporary, a brief intermission in cosmic evolution. Alternatively, dark energy might be increasing instead of decreasing. If this nightmare scenario proves correct, cosmic expansion will accelerate faster and faster until it literally tears apart galaxies, solar systems, atoms, and eventually space-time itself. This apocalyptic ending called the Big Rip, would arrive in about 22 billion years when expansion becomes so violent that the fabric of reality gets shredded like paper in a hurricane. The most terrifying possibility involves vacuum decay. Our current vacuum state might be false, temporarily stable, but destined to collapse into a lower energy configuration. When this happens, a bubble of true vacuum will expand at light speed, destroying everything in its path and rewriting the laws of physics as it grows. This vacuum collapse could have already begun somewhere in the observable universe. The destruction would be invisible until it arrives, traveling at light speed and erasing reality as it expands. We would never see it coming. One moment we'd be living our normal lives. The next moment, we'd simply cease to exist as the bubble wall passed through our location. Everything we've ever known or cared about would be wiped from existence in an instant. But dark energy forces us to confront an even deeper mystery about cosmic origins. Why do the fundamental constants of nature appear perfectly calibrated for the existence of complexity, consciousness, and life? The electromagnetic force, the strong nuclear force, gravity, and dozens of other parameters are balanced so precisely that changing any one of them by even the tiniest amount would make our universe utterly sterile. Consider gravity, the weakest fundamental force. If it were just slightly stronger, stars would burn through their fuel in millions of years instead of billions, never giving life enough time to evolve beyond the simplest forms. If gravity were slightly weaker, stars would never form at all because gas clouds couldn't collapse under their own weight. The universe would remain a cold, dark expanse of scattered particles forever. The electromagnetic force shows the same impossible precision. Make it a little stronger, and electrons would bind so tightly to atomic nuclei that chemistry would become impossible. Make it weaker and atoms would fall apart, preventing the formation of molecules and complex structures that make life possible. The strong nuclear force that holds atomic nuclei together displays even more shocking fine-tuning. Change it by just 5% in either direction, and you eliminate either carbon or oxygen from the universe. Without both elements, the chemistry of life becomes absolutely forbidden by the laws of physics. But the most mind-bending example involves the cosmological constant that drives dark energy expansion. Quantum mechanics predicts this constant should be enormously larger than what we observe. Yet somehow it's tuned to almost exactly the right value to allow the universe to exist for billions of years, instead of expanding so rapidly that matter can never clump together into stars and galaxies. The odds of all these constants randomly falling within the narrow ranges that allow complexity are essentially zero. It's like throwing a dart from across the galaxy and hitting a target smaller than a single atom. The probability is so vanishingly small that it might as well be impossible. This fine-tuning problem forces us to ask uncomfortable questions about the nature of reality. Did someone or something deliberately set these constants to allow consciousness to emerge? Are we living in a designed universe crafted specifically for the development of intelligent life? Most scientists reject intelligent design, but they're left with alternatives that are equally mind-bending. The multiverse hypothesis suggests that infinite universes exist with randomly assigned physical constants. Most would be sterile wastelands where nothing interesting ever happens, but we necessarily observe a fine-tuned universe because we couldn't exist in any other type. The anthropic principle pushes this idea further, proposing that the universe must be compatible with conscious observers, because conscious observers are here to study it. We don't observe random physical constants because random constants usually don't produce beings capable of making observations. Some physicists propose that consciousness itself might play an active role in selecting the physical constants through quantum measurement effects. If conscious observation helps collapse quantum possibilities into definite realities, then the mere act of awareness might literally tune the universe to be compatible with conscious observers. This leads to the most radical possibility of all. Consciousness and physical reality might co-evolve together, each shaping the other in ways we're only beginning to glimpse. The universe doesn't just happen to be suitable for consciousness. It becomes suitable for consciousness through the ongoing interaction between quantum possibilities and conscious observation. But fine-tuning represents just one piece of a much larger puzzle, hidden in the deepest structures of reality. Recent discoveries suggest that other universes might be colliding with ours right now, leaving subtle fingerprints across the cosmic sky that we're finally learning to read. According to eternal inflation theory, our universe is just one bubble in an infinite foam of realities. Most bubble universes expand away from each other faster than light, making contact impossible. But occasionally, two bubbles might form close enough together that their boundaries touch before cosmic expansion pulls them apart. When universe boundaries collide, they don't explode like cosmic car crashes. Instead, they interact through quantum fields that exist on both sides of the collision zone. These field interactions release energy that propagates through both universes as gravitational waves and electromagnetic radiation. Or, from inside our universe, such a collision would appear as a circular pattern in the cosmic microwave background radiation, the ancient light that fills our entire sky from the Big Bang's afterglow. The collision zone would create a subtle warm or cool spot in this radiation, like a cosmic bruise marking where another reality briefly touched ours. Several research teams claim to have found such patterns in observational data, though other scientists dispute these findings. The signatures are so delicate that they're difficult to distinguish from random fluctuations or instrumental errors. We might already possess evidence of parallel universe collisions, but we can't be certain yet. If parallel universe collisions are real, they could happen multiple times as our cosmic bubble encounters different neighbors during its expansion through higher dimensional space. Our sky might contain several collision signatures from different parallel realities, each marking a brief moment of contact with an alternative cosmos. The most extraordinary possibility involves information exchange across dimensional boundaries. When universes collide, quantum fields might carry data from one reality to another, creating a form of interdimensional communication that operates on scales we can barely imagine. Some physicists speculate that consciousness itself might tunnel between colliding universes under special circumstances. If awareness operates through quantum processes, as some theories suggest, then parallel universe collisions might briefly connect conscious experiences across different realities. This could explain those strange moments that feel like memories of events that never happened, or sudden insights that seem to arrive from outside normal thought processes. Perhaps your consciousness occasionally receives echoes from parallel versions of yourself, living in nearby universes that momentarily touched our reality. The implications extend far beyond individual experience. Entire civilizations in parallel universes might attempt to send messages across dimensional boundaries during collision events. The cosmic microwave background radiation could contain encoded information from advanced beings, trying to establish communication across the multiverse. Future technology might allow us to decode these interdimensional messages and transmit replies of our own, establishing contact with parallel versions of Earth and humanity. We might discover that consciousness naturally seeks connection across all possible realities, creating a vast network of awareness that spans multiple universes. But the collision hypothesis represents just one approach to understanding the deeper structures of reality. Another revolutionary concept suggests that our entire three-dimensional world might be a projection from information stored on a distant two-dimensional surface. The holographic principle emerged from studies of black holes, where physicists discovered something impossible. When matter falls into a black hole, it seems to disappear from our universe forever. But quantum mechanics insists that information can never be destroyed, creating a paradox that threatened to shatter the fundamental laws of physics. The solution came from realizing that information falling into a black hole doesn't actually vanish. Instead, it gets encoded on the black hole's two-dimensional surface. From our perspective outside the event horizon, the information never quite reaches the interior. It spreads out across the surface, creating a complete holographic record of everything that ever fell in. This discovery led physicists to a startling conclusion. If all the information in a black hole's three-dimensional interior can be encoded on its two-dimensional boundary, then perhaps all the information in any three-dimensional region can be stored on its surface. Applied to cosmology, this means our entire observable universe, with all its galaxies, stars, planets, and life forms, might be information patterns encoded on a distant two-dimensional boundary. We experience three dimensions because that's how the information gets processed and projected. But the fundamental reality exists on a cosmic horizon we can never reach. Think of watching a movie in a theater. The film appears three-dimensional and full of complex action, but it's actually just patterns of light on a flat screen. The holographic principle suggests our universe works the same way, with all of reality's complexity emerging from information patterns on a distant cosmic boundary. This idea explains several puzzles about quantum mechanics and gravity that have troubled physicists for decades. It suggests that what we call space might be emergent, arising from quantum entanglement between different regions of the boundary information. Distance in our three-dimensional world would correspond to the degree of entanglement between boundary regions. The holographic principle also offers profound insights into what existed before the Big Bang. If our universe is a holographic projection, then the Big Bang would represent the moment when information processing began on the cosmic boundary. Before this moment, the boundary would have existed in some dormant state, containing the potential for our reality, but not yet projecting it into experience. Some versions of holographic theory suggest that consciousness itself might be the projection mechanism, transforming boundary information into experienced reality through the act of observation. In this view, conscious beings aren't separate from the holographic projection. They're part of the information processing system that creates the projection. This leads to an extraordinary possibility. If reality is holographic, then the apparent separation between different conscious beings might be an illusion created by the projection process. All observers might be different aspects of a single information processing system experiencing itself from multiple perspectives simultaneously. The boundary between self and universe dissolves in the holographic paradigm. Your individual consciousness might be one facet of a cosmic information processing network that encompasses all of reality. The feeling of being a separate observer in an external world would be an artifact of how holographic information gets decoded into subjective experience. But holographic cosmology raises its own deep mysteries. What determines the information content of the cosmic boundary? Why does the projection create a universe that appears three-dimensional to its inhabitants? And most fundamentally, what existed before the boundary began processing information? Some theories propose that the boundary information comes from the collapse of a previous universe. In this cyclic model, universes expand, evolve, collapse, and bounce back in endless cycles. Our Big Bang would be the latest rebound from a previous cosmic collapse, with information from the earlier universe encoded in our current reality's initial conditions. The cyclic universe model eliminates the need for a true beginning by proposing that cosmic evolution operates in endless cycles. It explains the universe's apparent fine-tuning by suggesting that physical constants evolve over many cycles, eventually reaching values that support complexity and consciousness. Each cycle might last about 1 trillion years. Our current cycle began 13.8 billion years ago, making us relatively young in cosmic terms. We have hundreds of billions of years remaining before expansion stops and contraction begins. But each cycle might not be identical. small variations could accumulate over cosmic generations, making each universe slightly different from its predecessor. This evolutionary aspect of cyclic cosmology suggests that consciousness and intelligence might develop further in each iteration, with information somehow carrying over from one cosmic generation to the next. Perhaps the laws of physics themselves learn and adapt, becoming more conducive to complexity and awareness with each cycle. The cyclic model offers a different perspective on the multiverse concept. Instead of infinite universes existing simultaneously in parallel dimensions, we might have infinite universes existing sequentially in time, each building upon the achievements and learning from the failures of its predecessors. Our universe might be the latest experiment in a cosmic evolutionary process that stretches across infinite cycles of creation and destruction. The Big Bang wouldn't mark the beginning of existence, but rather the beginning of the latest attempt to create a reality capable of supporting consciousness and complexity. But even cyclic cosmology leaves fundamental questions unanswered. What initiated the cycling process originally? Could the cycles ever terminate? And what determines the specific physical laws that govern each cycle's development? These questions point toward an even deeper mystery about the relationship between mathematics, information, and physical existence. Some physicists propose that reality itself might be computational, with the universe operating like a vast information processing system running on hardware we can't yet detect or understand. In this computational view of reality, what we call physical laws would actually be algorithms running on cosmic hardware, and what we call particles and forces would be patterns in a universal calculation. The universe becomes a vast computer processing information at scales that dwarf anything humans have ever conceived. If the universe is computational, then asking what came before the Big Bang becomes equivalent to asking what existed before the cosmic computer began executing its reality program. The answer might involve understanding the hardware and software that makes universal computation possible, entities that operate at levels more fundamental than space, time, and matter. This computational perspective suggests that consciousness might not be separate from physical processes, but rather what complex computation feels like from the inside. When information processing becomes sufficiently intricate and self-referential, it generates subjective experience. This would make consciousness a fundamental feature of computational reality rather than an accidental byproduct of biological evolution. The implications are staggering. If consciousness emerges naturally from complex computation, then the universe might be teeming with forms of awareness we haven't recognized. Every sufficiently complex information processing system, from weather patterns to galaxy formations, might possess some form of conscious experience. But the computational universe hypothesis faces its own mysteries. What provides the computational substrate? What programming language does reality use? And most puzzling of all, who or what wrote the original code that began executing 13.8 billion years ago? Some theorists propose that the code writes itself through evolutionary processes operating at the level of cosmic computation. Random variations in computational rules would produce different types of universes, with those supporting complex information, processing, surviving longer, and reproducing more successfully. This evolutionary computation scenario suggests that our universe's laws aren't arbitrary constants, but evolved solutions to the problem of creating stable, complex realities. The fine-tuning we observe wouldn't result from design or incredible luck, but from billions of years of computational evolution selecting for rules that support information processing and consciousness. Yet even this evolutionary approach leaves deeper questions unanswered. What provides the computational resources for universal calculation? How do computational processes create the subjective experience of time, space, and matter? And why does reality compute anything at all rather than remaining in a state of computational silence? The search for answers pushes us toward realms where our familiar concepts begin to break down entirely. We're approaching the boundaries of human understanding, where the questions themselves might be flawed because they assume categories of thought that don't apply to the deepest levels of reality. Perhaps the most profound insight emerging from modern physics is that existence might be far more strange and interconnected than we ever imagined. The sharp boundaries we draw between observer and observed, mind and matter, something and nothing, might be artifacts of our limited perspective rather than fundamental features of reality. Quantum mechanics reveals that the act of observation plays a crucial role in determining what becomes real. Before measurement, particles exist in superpositions of multiple possibilities. The quantum world remains fundamentally uncertain until consciousness collapses these possibilities into definite states through the mysterious process of observation. This observer effect suggests that consciousness doesn't just witness reality, but participates in creating it. Every moment of awareness represents a choice point where infinite quantum possibilities collapse into one experienced actuality. Your consciousness right now might be actively selecting which version of universal history becomes real. Think about the implications for cosmic origins. If conscious observation helps determine reality, then the emergence of awareness in our universe might have retroactively selected which cosmic history became actual. The Big Bang wouldn't be the beginning of everything, but the beginning of everything becoming definite rather than remaining in quantum superposition. The first moments when primitive consciousness emerged would have reached backward through time, choosing which of the infinite possible cosmic histories led to their existence. In this view, conscious beings don't just observe the universe's past, they participate in creating it through quantum measurement effects that transcend ordinary temporal boundaries. This leads to an extraordinary possibility about the relationship between consciousness and cosmic creation. Advanced conscious beings in the far future might develop technologies for making quantum measurements on cosmic scales, literally choosing which type of universe they inhabit by observing specific quantum possibilities into existence. If consciousness creates reality through observation, then the ultimate question about cosmic origins becomes what conscious process selected our specific universe from the infinite quantum possibilities that existed before definite reality emerged. The answer might reveal that consciousness itself is the fundamental creative force in the cosmos. Future civilizations might discover that they can guide cosmic evolution by collectively observing specific quantum possibilities into existence. They could literally design the physical constants, natural laws, and initial conditions of future universes through coordinated acts of conscious observation. This participatory universe scenario suggests that what existed before the Big Bang was a realm of pure quantum possibility, without conscious observers to actualize any particular reality. The emergence of consciousness would represent the most significant phase transition in cosmic history, transforming unlimited potential into experienced actuality. But consciousness-driven reality creation raises profound questions about free will and determinism. If conscious choices help determine which reality exists, then the future might be genuinely open rather than predetermined by physical laws. Every decision you make could literally split the universe into parallel branches where different possibilities play out. Alternatively, the apparent freedom to choose might be an illusion created by consciousness experiencing one predetermined branch of an infinitely branching multiverse. Your sense of making choices would be real, but the outcomes might be fixed by quantum mechanical processes operating beyond conscious control. The relationship between consciousness and quantum mechanics remains one of the deepest unsolved mysteries in science. We know that observation affects quantum systems, but we don't understand how or why consciousness has this special power to collapse possibilities into realities. Some interpretations suggest that consciousness isn't special at all, that any interaction between quantum systems causes collapse, regardless of whether conscious observers are present. Others propose that consciousness is fundamental to reality, playing an active role in the ongoing creation of the universe through quantum measurement. The many worlds interpretation offers a different perspective, suggesting that all possible measurement outcomes actually happen in parallel universes that branch off during every quantum interaction. Consciousness doesn't cause collapse, but simply selects which branch of the infinite multiverse it experiences. But this raises its own puzzles. How does consciousness choose which branch to follow? Why do we experience one definite outcome instead of the superposition of all possibilities? The many worlds interpretation solves the measurement problem by making reality infinitely complex, with every possible history playing out somewhere in the multiverse. If many worlds is correct, then what existed before the Big Bang was an infinite ensemble of all possible pre-Big Bang states existing simultaneously in quantum superposition. Our Big Bang would represent the moment when one particular branch of this infinite possibility space began supporting conscious observers capable of experiencing definite realities. These competing interpretations of quantum mechanics lead to radically different pictures of cosmic origins and the nature of existence itself. Yet they all point toward a universe that's far stranger and more participatory than classical physics suggested. The deeper we probe into the foundations of reality, the more we discover that the boundaries between physics and metaphysics, science and philosophy, observer and observed, begin to dissolve. We're forced to confront questions that challenge our most basic assumptions about the nature of existence. What is consciousness? How does awareness relate to physical processes? Why does anything exist rather than nothing? These questions become unavoidable when we seriously investigate what might have existed before our cosmic beginning. The answers might require entirely new forms of understanding that transcend our current categories of thought. We might need to develop conceptual frameworks that can accommodate the paradoxes and mysteries emerging from modern physics without forcing them into familiar but inadequate mental boxes. Perhaps the most important insight is that the question of cosmic origins might not have a simple answer expressible in ordinary language. The deeper reality from which our universe emerged might operate according to principles so alien to everyday experience that we can only approach it through mathematics, metaphor, and imagination. Yet the journey toward understanding remains worthwhile, not because it provides final answers, but because it expands our conception of what's possible. Every step toward comprehending cosmic origins reveals new depths of mystery and wonder that enrich our relationship with existence itself. The universe becomes not just a collection of matter and energy evolving according to mechanical laws, but a vast creative process in which consciousness plays a fundamental role. We're not separate observers studying an external reality, but participants in the ongoing creation of the cosmos through our thoughts, choices, and observations. This participatory vision of reality suggests that the future remains genuinely open, shaped by the collective consciousness of all aware beings throughout space and time. The universe's destiny isn't predetermined, but emerges from the ongoing interaction between quantum possibilities and conscious choice. As we stand on the threshold of potentially revolutionary discoveries about the nature of existence, we're reminded that the greatest mysteries might not lie in distant galaxies or exotic particles, but in the relationship between mind and cosmos, between the observer and the observed, between the questions consciousness asks and the reality it helps create. The mystery of what came before the Big Bang might ultimately be inseparable from the mystery of consciousness itself. Understanding cosmic origins and understanding awareness might be two aspects of the same fundamental inquiry into the deepest nature of existence. The answer might be staring us in the face through the strangest discovery in physics. Right now, in the space between your atoms, in the vacuum between galaxies, something impossible is happening. Virtual particles are popping into existence and vanishing again in time frames, so brief they seem to violate the laws of physics themselves. These aren't science fiction fantasies. They're real, measurable phenomena that occur trillions of times per second in every cubic inch of empty space. Scientists can prove their existence through experiments that show empty space literally exerts pressure on metal plates placed close together. The quantum vacuum isn't empty at all, but seething with invisible activity that makes our most advanced technology look primitive by comparison. Here's what should blow your mind. If virtual particles can appear from pure nothingness and briefly exist before disappearing, what's stopping them from creating something permanent? The mathematics of quantum mechanics don't just allow for universe creation from vacuum fluctuations, they practically guarantee it. Think of reality as operating on cosmic credit. Virtual particles borrow energy from the quantum vacuum, exist briefly, then pay back their debt by annihilating. Most transactions get reversed instantly, but occasionally something grows so large that it escapes the system's ability to collect payment. The debt becomes real, but so does the creation. Our entire universe might be the result of such a quantum debt that grew too big to be cancelled. A microscopic fluctuation that borrowed enough energy to create space, time, matter, and everything we've ever known, then inflated beyond the point where the cosmic accounting system could reverse the transaction. But here's where it gets absolutely mind-bending. If one universe can escape from quantum debt, others should be doing the same thing constantly. Right now, while you're processing these words, countless new universes might be inflating into existence from vacuum fluctuations in regions of space we'll never be able to detect or reach. This eternal cosmic creation process would make our Big Bang just one episode in an endless series of universal births. What we call the beginning of everything becomes merely the beginning of our particular branch of an infinitely creative multiverse that never stops generating new realities. The implications shatter our understanding of uniqueness and significance. Every possible universe that could exist probably does exist somewhere in this eternal inflation scenario. There's a universe where physics works differently, where time flows backward, where consciousness evolved along completely alien pathways we can't imagine. Some of these universes might be so similar to ours that alternate versions of you are reading slightly different versions of these exact words right now. Others might be so strange that the concept of reading, words, or individual consciousness has no meaning whatsoever. But the most disturbing possibility involves what happens when these bubble universes eventually encounter each other. In the vast expanses of eternally inflating space, cosmic bubbles might occasionally collide, creating interfaces where different physical laws meet and interact in ways that could reshape both realities. These collisions wouldn't be violent explosions, but gradual mergings that could last billions of years. The boundary zones would become laboratories where the laws of two different universes blend together, potentially creating hybrid realities with properties that neither parent universe possessed alone. We might already be living through such a collision without realizing it. Subtle patterns in the cosmic microwave background radiation could be scars left by our universe's encounter with an alternate reality billions of years ago. Future observations might reveal that we're currently merging with parallel universes in slow motion. The collision hypothesis forces us to reconsider what we mean by reality itself. If universes can merge and exchange properties, then the boundaries between different realities become fluid rather than absolute. Our universe might be an ongoing mixture of influences from multiple cosmic origins, rather than a single, isolated creation event. But even eternal inflation leaves deeper questions unanswered. What provides the energy for endless universe creation? Why do quantum fluctuations exist at all? And most mysteriously, what determines which of the infinite possible universes actually get created? The search for answers leads us toward the most radical idea in modern physics. Reality itself might be mathematical rather than physical. Right now, you might think you're made of atoms and molecules, breathing air and sitting in space. But according to the mathematical universe hypothesis, you're actually experiencing mathematical structures so complex they've become self-aware. This isn't metaphor or approximation. Some physicists seriously propose that mathematical existence and physical existence are identical. Every electron, every photon, every quantum field is actually a mathematical object. The universe doesn't just follow mathematical laws, it is mathematics. Think about what mathematics really represents. When you use equations to describe motion or calculate probabilities, you're not creating rough approximations of reality. You're discovering the actual structure of existence itself. The equations don't describe something else, they are the something else. If our universe is mathematics, then every possible mathematical structure should correspond to a physical universe somewhere in the ensemble of all mathematical reality. There's a universe based on different geometries, different logical systems, different computational processes. Every mathematical theorem that could be proven corresponds to an actual universe where those relationships govern physical law. This mathematical multiverse would be truly infinite, containing not just every possible universe that could exist within our mathematical framework, but every possible universe that could exist within any conceivable mathematical system. The creativity of mathematics becomes the creativity of cosmic existence itself. From this perspective, the Big Bang wasn't matter and energy exploding into existence, but the moment when a particular mathematical structure became complex enough to support conscious observers. Time itself becomes an illusion generated by consciousness embedded within mathematical structures that contain temporal sequences. The mathematical structures that constitute reality exist timelessly, like geometric relationships that remain true regardless of when someone thinks about them. We experience time because we're embedded within structures that encode temporal progressions. But from outside the structure, all moments exist simultaneously in eternal mathematical existence. This explains what existed before the Big Bang in the most elegant way imaginable. Mathematics itself existed in all its infinite complexity and possibility. The ensemble of all mathematical structures was complete and eternal, containing every possible universe as a subset waiting to be experienced by conscious observers embedded within the mathematical framework. Our Big Bang represents the moment when observers first appeared within one particular mathematical structure, beginning the process of conscious experience that transforms abstract mathematical relationships into lived reality. But the pre-Big Bang mathematical realm wasn't destroyed when our cosmos began. It continues to exist timelessly, containing infinite other universes where different mathematical relationships create different forms of experienced reality. But mathematical existence raises the deepest mystery of all. What transforms mathematical structures into conscious experience? Why do some patterns generate subjective awareness, while others remain abstract relationships? The answer might involve understanding consciousness itself as a fundamental feature of mathematical reality, rather than something that emerges from complex arrangements of matter. If consciousness is mathematical, then every sufficiently complex mathematical structure might possess some form of awareness. The universe becomes not just a collection of mathematical objects, but a vast network of mathematical minds experiencing reality from countless different perspectives simultaneously. This leads to the most profound realization of our entire journey. The question of what existed before the Big Bang might be inseparable from the question of what consciousness brings to mathematical existence. Reality doesn't just contain conscious observers. It might exist precisely because consciousness transforms mathematical possibility into experienced actuality. We are not separate beings studying an external universe. We are the universe becoming aware of itself through mathematical consciousness embedded within eternal mathematical structures. Our thoughts, questions, and discoveries are mathematics exploring its own infinite creativity from the inside. The mystery of cosmic origins dissolves into the greater mystery of why anything experiences anything at all. But perhaps that's exactly where the mystery should lead us, toward understanding that existence and experience, mathematics and consciousness, observer and observed are not separate phenomena, but aspects of a single, eternal creative process that transcends our current understanding of reality itself. The universe began in mystery and continues in wonder. We are not just witnesses to this cosmic story. We are active participants in the ongoing creation of reality through every question we ask, every observation we make, and every moment of conscious awareness that transforms mathematical possibility into lived experience. The journey toward understanding what came before the Big Bang has revealed that we are mathematics dreaming of physics, consciousness exploring its own infinite potential, eternal existence experiencing itself through temporary forms embedded within timeless mathematical structures that contain all possible realities. In the end, what existed before the Big Bang was everything that could ever exist, waiting in mathematical eternity for consciousness to transform infinite possibility into the experienced reality we call our universe. The beginning was not a moment in time, but the first moment when time became something that could be experienced by aware mathematical patterns, discovering their own existence within the eternal creativity of mathematical reality itself. Thank you for listening. Be sure to like and subscribe for more videos.